Hello and welcome to my DevSecOps series. Here in Germany it's winter right now and the forests are quiet. The snow slows down everything and it's a beautiful time to move undisturbed through the woods. Here you can pursue your thoughts, and I had to think about a subject that customers and participants at conferences ask me repeatedly. The question is almost always, what are the quick wins or low-hanging fruits if you want to deal more with the topic of security in software development? And I want to answer this question right now. Quite often people are asking me, what are the low-hanging fruits if you want to start with DevSecOps? So what are the quick wins? What I should have a look on first? If we are discussing in a bigger team inside the company with the economic part, with the tech part and so on, it's quite often the case that we are meaning the same stuff, but we are using different words. But let's start with the thing like make or buy. Mostly a software developer is not using this term, but the economic part of the company is quite often asking for if this is easier to buy or make it sense to do it by ourselves. So make or buy. What they want to have with this they want to have quite fast usability of some functionality, or they want to have some solution fast because they are just paying money for it, and then they can use it. So they can start earning money with this again on their side. If I'm buying something or if I'm adding a dependency, most likely I have exactly the functionality, or quite often you have even more functionality as you really need. But what happened if there is a bug? What happened if there's a vulnerability? What happened if you need a slightly change in the functionality? So how fast you can work around it, how fast the original inventor or the core team of this product is helping you. So is this really easy? It's the same with a make. With a make by yourself, you have to learn first how to implement it. You have to do all this stuff. You have to deal with vulnerabilities by yourself, but you can quite easily change the code. You don't have to ask someone on the other side. You have to check your code against vulnerability, but your own code. So we have pros and cons with make or buy, but the good thing is, let's talk about exactly this make or buy on all levels, so you're talking about the same thing with the same words. Okay, next thing I want to have an eye on is a full tech stack from one application. As example, I'm just choosing Cloud Native, for example, and the first layer we have is an application. So assume that we are writing this application in Java, so we have a Maven that is managing the dependencies, and quite often I'm adding dependencies and then I'm coding my stuff. In this layer, the make is big compared to the most other layers, because here I'm writing a lot of code. But if you are comparing make or buy, the amount of dependencies or the amount of lines of code you are adding as a dependency is mostly way bigger compared to what you're writing by yourself. If you want to go to the Cloud Native stack, the next thing would be how to run it in Linux. And here, if you are looking at this operating system, most likely you are not writing kernel drivers, so you are adding some configuration, you are adding some binaries. So the whole composition of this operating system is mostly a composition or configuration of dependencies. You're using binaries, you're not writing a kernel driver by yourself. After this, you want to make sure that it is running inside Docker. And the first statement in a Docker file is a from statement. So you even start with adding a dependency with a base layer you're using, and then you're adding some configurations, you're adding some binaries, and so on and so on. But most likely you are not writing code for the Docker stack itself. So you're using the whole tech stack as a dependency. After you have the Docker file and everything is running in a single instance, you want to orchestrate it in a Kubernetes cluster. And here you have Helm charts, you're composing based on existing elements, your whole system. And again, the make or buy is most likely in a way that you're buying more, you're adding more dependencies, you're configuring, but you're not writing stuff for the Kubernetes universe itself. So you're not writing an extension for Kubernetes, you are using Kubernetes. At the same time, you should have a look at the DevSecOps part. So Cloud Native is explicitly mentioning DevSecOps, but even if you're just going with DevOps, you have some tool stack that is managing the whole process. For example, you're using a CI environment. So you're not building all this stuff by yourself. You're not writing a bunch of shell scripts to compile something, to combine something, to package it. You're using a CI environment and you're configuring your build pipeline. And that's it. So even here, you're adding more dependencies as writing stuff by yourself. So in the end, if you're looking at the whole tech stack, the dependency part is the most dominant part here, because you're adding a huge amount of external components and lines of code indirectly compared to what you're doing by yourself. And this means that you should have an eye first on dependencies. The next thing I want to have a look at is application itself. Why? I'm cutting out all the other pieces, so the Docker layer, the Linux layer, and the Kubernetes layer, because here the make or buy is more for the buy compared to the application itself. So if the idea, what I'm explaining, fits to the application itself, where the make part is the biggest compared to all other layers, then it fits to all other layers as well. So what I want to say here is, if you are dealing with the term DevSecOps, or if you want to know what the tools can do, you have two things. You have first the compliance issues, and the second thing, you have vulnerabilities or security issues. And this means you have to define two paths. So what are you doing with compliance issues? Compliance issues means that in your dependencies, or in some transitive dependencies, you are using a license that is not good for this case, for this business case, or for this environment where this dependency is used. For example, you're using a GPL in a part of the application that is not allowed for you. But the main thing here is you need a lawyer or someone who knows all this stuff and will decide what are the good license and what are the bad license for this dedicated part of the project or in general. And then the machine can just constantly scanning all dependencies and will say, yes or no. And what you are doing as a human, if there is a violation, well, you just have to change it. So you have to remove this dependency, and you have to make sure that you are adding a dependency that is running under the right license for you. On the other side, we have vulnerabilities. Vulnerabilities, you don't need a lawyer in the beginning, but the machine is scanning again constantly all dependencies and transitive dependencies, and then there is a known vulnerability found. And now the human has to work way more than compared to the compliance issue, because now you have to check if this vulnerability is critical for you, if this is a vulnerability you can deal with, handle, you can rate this vulnerability, you can analyze all this stuff. So you have to decide if you're changing the dependency, if you're changing the version, if you're coding some stuff and writing a patch by yourself. Whatever you're doing, it is a decision that must be done fast, and it must be done by you, not by the machine. And this is a big difference here. So thinking about vulnerabilities in compliance means vulnerabilities is a recurrent effort for you, because you will get the information from the machine, and then you have a time-critical task because you have to decide, you have to act. And with compliance issues, you have in the beginning a bigger amount of work, but mostly the project are not changing the license all the time. Sometimes it's happening, so it's good that the machine is scanning again and again, and that's not a one-time shot. But most likely, if you are choosing a bunch of dependencies or from a dedicated field of dependencies, then you just have to check or have to deal with these license issues once. The next thing I want to have an eye on is the difference between the behavior of compliance issues and vulnerabilities. So looking at on all different tech layers, and if you have compliance issues in one layer, then this is a singular point. So it's just existing in this layer. So you can have a compliance issue in the Docker layer, in the Kubernetes layer, in a dependency inside your application, whatever. But every compliance issue is just a single dot, and then you have to remove this single dot. It's different with vulnerabilities. So vulnerabilities you can have in all different layers as well, but even if there's a vulnerability in one single layer, it can be part of an attack vector that is combining different vulnerabilities. So you're looking at one vulnerability, and this is maybe not critical, but in combination with some other vulnerabilities, it could be just a complete blocker for your system. So having in mind that compliance issues are singular points, so you have to remove them, that's it. But vulnerabilities, if you have a amount of vulnerabilities, it's not the full amount of attack vectors. The amount of attack vectors, so the combination of vulnerabilities can be even higher than the pure amount of vulnerabilities. And have in mind, the combination of low-risk vulnerabilities can be in some very critical thing. Okay, talking about the vulnerabilities and what is a time-critical thing here. So if you're dealing with vulnerabilities, time is a critical thing, and because as soon as this vulnerability is known, other people will just use it, and this is exactly the risk you want to minimize. So having a look at the evolution of this information, or the different parts we can optimize so that this time from vulnerabilities found up to fixes running in production is minimized as much as possible. So if there is a vulnerability, we have no possibility to speed up the time that a vulnerability is found. So if you're not a security researcher, then most likely you're just waiting that someone will find this vulnerability. It depends on the person who is finding this vulnerability. This information will be public after this, yes or no, because if it's the wrong person, then they know about the vulnerability and they are not sharing this information. If you have a white hacker, then it's good, because then he will go to someone and will report it. And now we have the next step in this game. So the information about the vulnerability is now available. So until vulnerability is here and vulnerability is found, we have no possibility to influence this one. The information is now available and is now public available. So from found to information is public available. This is a time that can be influenced by different things. For example, if it is a product, sometimes the security researcher, after they found a vulnerability, going to this company and say, okay, we will wait for 2 weeks until we are making this information public, so that you have time to fix it, and then you have immediately a patch, or the patch is already rolled out, or whatever. So even here we have no choice, no possibility to speed it up. The next thing is the information is now public, and now it will take some time until you can consume this information. This is the first time, or it's a first step you can influence somehow in terms of time, because here most likely money will help you, because we have these commercial vulnerability libraries, these professional services that will aggregate and that they will buy this information and all this stuff. We have free resources, we have commercial resources, paid resources, but everything together means that you have to aggregate different resources. So it's not this single resource and then it's done. So you need to merge different information provider to one single database. So you can do it by yourself if you have the resources and if you can subscribe to many different services. But the other thing is that you are going to an aggregator, and one aggregator is, for example, X-Ray from JFrog, because we have a team here that is doing exactly this. So consuming all public or commercially available resources, merge them to one database as fast as possible, classifying them and pushing it to the instance, to the different X-Ray instance. So the only thing you can do here is paying some money to have this information, or to have it fast. But the last step, this is a very critical one, and mostly this is a quite long time period, because after this information is consumable for you, you need time until a fix is running in production. And this you should have an eye on. So this is a critical thing, because this you can influence to 100%. What I want to say here is that if you're now able to consume this information, you know about this vulnerability, then you can, for example, change versions of your dependency to get rid of this vulnerability, or change the dependency itself. So what is here the critical thing? The critical thing is, first of all, that you have automated everything. So you're in the field of DevOps or DevSecOps, means you have a CI environment, and changing something until it's running in production is completely automated and fast. But the real good safety belt here at this point is a very good test coverage. Because if you have a very good and strong test coverage, you can change versions, not in minor versions, even major versions. So you can just play with the composition of versions until everything is running well, and you are minimizing the full amount of vulnerabilities. And this means you need a good safety belt, and the best safety belt here at this point is a perfect test coverage. I want to highlight here at this point that pure line coverage is mostly not efficient enough, or not good enough. So have a look at mutation testing. Mutation testing is a very strong test coverage against your code. And if you want to know a little bit more about this one, check out my YouTube channel. I have a dedicated video about mutation testing itself. I will explain how to do it, how to start with this, what's the mechanics and the mathematics behind it. And yeah, I really recommend having a look at, having an eye on different test coverage or test techniques, and harden your test coverage. And this will be the best safety belt you have, because with this you can speed up the time, or you can minimize the time between you can consume the vulnerability information until it's running in production. So time to market, and this must be short. We saw now that time is critical, and that good test coverage is helping you to change dependencies and all this stuff. But for these examples, I just mentioned the application itself and Maven and changing dependencies here. But we have vulnerabilities in the Docker layer, in the Linux layer, in the Kubernetes layer, in the application layer, and so on and so on. And even if you're looking, for example, at an application itself, and you're using, for example, the open source tool Vardin for graphical user interfaces, you're dealing with Maven on one side, but indirectly you're dealing with NPM for the web component part. So it means you will have the challenge to deal with polyglot environments anyway, so even inside your application, or if you're looking at the full tech stack. So it's good advice to search for tools that are able to give you the information about vulnerabilities over all tech layers. So it makes no sense to focus on a tool that's just scanning Docker layers. It makes no sense to focus on a tool that's just only scanning Maven dependencies. So what you need is something that is able to deal with all these dependencies, with all these packet managers. And with Artifactory and X-Ray, we have exactly this combination. So we have with Artifactory the possibility to deal with all these different packet managers, and X-Ray is understanding them and will give you the full impact graph. So you will be able to see there is a vulnerability in this jar, and this jar is part of this Docker layer, and this Docker layer is used in this Helm chart, for example. So how to do this one? You can activate a free tier, so if you want to try it out by yourself, and then you have Artifactory and X-Ray. But how to do this and how to shift left as much as possible, we will see in a second. Okay, we know that with Artifactory and X-Ray we will get the full impact graph, so the information about vulnerabilities in all layers. But how to deal with this was a practical approach, and it would make sense to remove vulnerabilities or kill vulnerabilities as early as possible. And this means in the first layer, that is a base for everything, and this is application itself. So this what you are coding. So in your daily life, in your daily work, you are adding the first dependencies, you are adding the first vulnerabilities. So it would make sense to remove them as early as possible. What you could do is, and mostly I see this approach that people are doing it with the CI environment. This is not bad. So the CI environment that is checking against vulnerabilities is good, but it's too late. Why? You're adding a dependency, you're coding some stuff, you're making a commit, you're pushing this stuff to the CI environment or to your Git repository. The CI environment will start working. And then after a few minutes, you will get the feedback, okay, now there is a break because you have a vulnerability. But even at this time or this point, you spend so much time because you added a dependency, you worked already, and then maybe you have to change the dependency or not only the version, the dependency itself maybe. So it would be way better if you would get this information about vulnerabilities immediately after adding a dependency, and this inside your IDE. And we have this one, it's an IDE plugin, it's open source, so you will find it on GitHub. So if you have some bugs or feature requests or whatever, check it out. Or if you want to use it for a different IDE we are not supporting so far, just use this one as a reference. We are supporting right now IntelliJ, VS Code, Eclipse, and I don't know exactly all of them, but it's constantly, we are constantly adding more IDEs. Okay, time for the conclusion. With the JFrog free tier, you have the tools in your hands to practice ShiftLeft and pushing it into your IDE. Create repositories for all included technologies, use Artifactory as a proxy for your binaries, and let X-Ray scan the full stack. With this, you have the complete impact graph based on your full stack and the pieces of information about known vulnerabilities as early as possible inside your production line. You don't have to wait until your CI pipeline starts complaining. This will save a lot of your time. If you like this presentation, I would appreciate to have you as my new subscriber on YouTube. I have 2 channels, one in English and one in German. On my channel you will find videos about the topics Core Java, Kotlin and DevSecOps. Please give me a thumbs up and see you on my channel.